Okay, let's move to the final speaker, Mr. Dmytro Yakovenko, Head of International Sales in BTU Center Group of Companies. Dmytro is going to talk us about microbial technologies for soil generation and stress resilience, insights from over 2,500 trials, and new formulation advances. Please welcome Dmytro.
Greetings to everybody. Anna will give me a nice idea. We need to work also for soil generation. Greetings to everybody. I believe some of you already have seen me somewhere. And 2 years ago, we started one project because again, in my previous background, I was an analyst and it still lived in me a little bit. And working with big amount of data which you have generated, we always seek what we can, how we can generalize that. So I will show you in a while. So for those who don't know us yet, we are a company from East Europe, more than 500 millions. We apply biologicals in big scale, more than 4 million hectares each year. And now a little hint that when we 2 years ago started generalizing our data, we make a careful thesis. We have more than 1,000 trials. When we calculated, it was more than 2,300. So this time I was also careful. I submit like 2,500, but in fact it's more than 3,000. We are generally based in Central East Europe with our products. We also have office in Germany, part of IBMA, and you can find our products in 25 countries worldwide. Here is how our factory looks like, and we develop the technologies to keep efficiency, purity, and stability of our products in production in big scale. This is how our office looks like in Kyiv and in Germany. And as you can see, we are trying to be near you and measure industrial events like here in UAG. So coming closer to the topic. So as I mentioned already, there are more than 3,000 studies, because again, when most of us have a lot of data, field studies, scientific studies, laboratory studies, and when you look on such amount of data one by one, it will take you a few weeks. So we try to get some extracts and we will continue analyzing it from inside out. So if we take a look on it in general, we have around 20 years of data in our database, more than 3,000 studies, and in these studies, average kind of success rate is more than 86%, which I believe for biologicals is quite sufficient. As we are maybe not as a lot of companies in the industry, we come from the different side, because a lot of companies come from horticulture, application of biologicals in horticulture. We start from the field crops. Big amount of data from our database, almost 3,000 studies are from the field crops. So you can see that in field crops, average efficiency is a little bit lower compared to vegetables or root crops, but still it's sufficient and cost efficient as well. So as you can see, again, we have around 2,000 studies in grains and industrial crops with average efficacy 8-9%. Then on legumes like soybeans, peas, average efficacy is a little bit higher. Again, we work here a lot with inoculants, but also another supplements. And quite interesting is to find out that root crops like potatoes, sugar, beet are quite reactive to biologicals, and here average efficacy was up to 19%. So if we look on this database by products categories, you can see like starting from the top, micronutrients. Most of farmers and companies work with such a category of products, and here from our experience, average increase of the yield is 11%. So some of the companies are already working with biologicals like for nitrogen fixation, phosphorus solubilization, and it's always interesting for them to do what they can expect in comparison to what they have get used to. So here you can see that more or less additional yield from this category of products is quite similar to micronutrients, which is quite good. Quite interesting also is like to find out inoculants also used by a lot of companies. In some countries like Brazil are used by most of the farmers. So from our experience, average increment is also around 10%. But in our database, we find out there are some synergies which improve efficacy of inoculants. So first of all, maybe for around 5 years, we applied together with inoculants Microbial products. In this case, you can expect efficacy around 14%. But when I had a look on the database this time, I found out it's quite interesting that quite a good synergies to inoculants are phosphorus-solubilizing bacteria. So in this case, we reach up to 16% increments of the yield. Then we also apply biologicals in different ways for seed treatment, furrow, soil treatment, foliar treatment, and different combinations. So you can see that more or less each way of application is sufficient, but also it's interesting to see the possible synergetic effect. For example, soil and seed treatment can have synergy, but not kind of double the effect, because when you, for example, treat the seed, you already have some presence of bacteria in the rhizosphere, and then there is no so big increment from total treatment of the soil and the opposite. But at the same time, combinations like soil plus foliar applications and seeds plus foliar applications are quite efficient, and you can see it twice the figures. So besides that, we have some amount of data where we also have specific pH levels of the soil, around 1,000 trials. And from this, we can see that more or less biologicals are quite consistent in different pH level of the soil, like 20%. I mean, in acidic soils, we have surprisingly around 20% increments of the yield, and also in neutral, it's quite consistent, but also with higher pH, higher than 7, we also have quite consistent increments. And there are some popular questions when you come to some areas with kind of critical acidic soil or alkaline soil. There is a hypothesis, okay, we have acidic soil, bacterial product will not work here. So from our experience, indeed, bacterial product work a little bit worse on acidic soil, but still efficacy is quite sufficient. And the same for fungal containing products. You can see that in both acidic and alkaline soils, they have good efficacy. So we had a look on the 3,000 studies from in general, so let's go one by one. So let's look on some categories of global agricultural challenges we work with. So first one is organic matter and soil fertility management. Here we work with complex product called Ecostern. I will show you some data about that. Then we work with biofertilizers for phosphorus utilization and nitrogen fixation. We have quite a sufficient amount of data how to substitute specific amount of fertilizers. And then we work with some biostimulants which help plants to grow in stressful conditions. So let's look on some of them and some of the data that we have. So first one is Ecostern. Again, it contains some bacteria and fungi like Bacillus trichoderma, some also anaerobic bacteria, and normally we apply it after harvest to accelerate the decomposition of plant residues. So we started working with this technology more than 15 years ago. And the main idea was again to enrich soil with organic matter. So we have plenty of 3 to 5 years studies with scientific institutions and with farmers, which prove this positive influence on accumulation of organic matter in soil. We also checked the efficacy on different types of soil to prove that it accelerates the decomposition. And when we accelerate the decomposition of plant residues, we also have a positive influence on soil density. Quite recently, we make a 3-year study with one of our big partner and customer, Kernel, who is the biggest supplier of sunflower oil in the world. They have around 500,000 hectares, and they say there is no field in the company which is not treated with this technology. So at the moment, we are working with them to have kind of accredited data to include this technology in carbon programs. So according to this study, during 3 years we succeed to increase the level of organic matter in soil up to 0.3%. And when we calculate this amount to CO2, we can see that it's up to 8 tons of carbon, which is kind of prevented from being evaporated. And and take into account the cost of 1 ton of CO2, which is now around like 70 to 90 euros per ton. It's quite a sufficient additional profit to the farmers. But the organic matter is not the only thing. We also position Ecostern as a tool in regenerative agriculture, and there are some situations when soil is especially degraded, for example after floods, sometimes after some herbicides application, or for example after solarizations. In this case, you can see that soil is kind of dead and not functional. And there are a lot of processes in soil happen with the help of microbes. So our idea is to return functional microbes to the soil, and as you can see, using the BioAg method to measure enzymatic activeness of microbes, we can return life and functions to the soil. We tested this approach also in fields in Germany on regenerative farms with no-till practices, and we find out that we can increase this activeness of microbes like from 10 to 30%, and also ecophysiological biodiversity of them. And coming closer to Spain, we did some tests around Valencia last year, combining these soil measurements and NDVI measurements using one soil tool. So what we can see during a quite stressful period of time of drought during June, we succeed to preserve enzymatic activeness in soil, because on control it was decreased for 20%, and on trial it was decreased just for 10%. And it's interesting to see that it also correlates with what we have seen with NDVI indexes. If on control the vegetation mass kind of was not developing so active in this way, the decreased the NDVI index on the trial, we keep it on a better level and even improved. So in fact, when we go to field with this technology, very often we work with the plant residues. So you normally in these slides you can see my hands too. And what I wanted to show in this slide is that really, despite the fact that bacteria are origin from East Europe, we already get experience with this technology starting from Ecuador and to Asia, Middle East, North Africa, so it's quite universal for different conditions. And the topic of important for now, using this technology you also can decrease application of nitrogen fertilizers for direction of plant residues decomposition. So really this technology could cost you zero, because you can compensate some amount of nitrogen. But speaking about fertilizer substitution, we have a separate direction for that, and also a few years of experience that you will see. So here we work with nitrogen fixing product Azotohelp and with phosphorus utilizing technology Groundfix. And we started tests with this technology around 7 years ago with main crops we work with, like soybeans, sunflower and corn. We reduced 30% of fertilization, and it was very interesting to find out that with this approach you can increase the yield even higher than with 100% control. And we observed that on all 3 crops. So we continue with that studies. Again, we prefer to have 3 to 5 year studies in different conditions, different crops. And now also we have different formulations of this product, because we develop more stabilized versions. And you can see that also 30% of fertilization, in this case on corn, we also succeed to substitute without loss of the yield, even with better level. And we test this approach in different areas now. For example, in Greece on cotton, we succeeded to substitute 20% of NPK, also with improvement of comparing to control. And that works not only in Europe. Again, this example is from Ivory Coast. We tested there also the program with Azotohelp and Groundfix, substituting 25% of fertilizers. But again, important to understand this technology, you're not obliged to reduce fertilizers. This technology also improves yield in standard technology, but when you reduce the fertilizers rates, you can have some additional savings. And speaking about nitrogen substitution direction, again, we have some specific data now during 2 years of corn. We reduce fertilization rate for 25%, 30 kilograms of nitrogen, and we tested different application methods of nitrogen fixing bacteria. Soil application and foliar application and combination. So more or less both ways are sufficient, and we practice both of them. But in fact, maybe 70–80% of our customers use this technology foliarly because it's more maybe technological for them. And another example, again, we have 3 years of data in the Czech Republic. It's quite critical. Normally we don't recommend it to farmers, but our partner made a stress test to substitute 160 kilograms of urea, which is roughly around 50 kilograms of nitrogen. So also in this scheme they substitute nitrogen by as a product without loss of the yield. And additional direction which we work with recent 5 years is abiotic stresses, especially drought. And in this direction we also include a product which is organic aromatic acid-based polysaccharides produced by bacteria, Liposam. Normally we use this product to improve the efficacy of what you spray on the plant surfaces or in the soil, because it also improves rainfastness. But recently, when we did a 3-year study for drought tolerance, we tested different products from the market, like amino acids, seaweeds, humic acids, microbials, also Liposam. It was very interesting for us to find out that one of the best performer was nitrogen fixing product, and the second place was this polysaccharides-based argument. And we didn't stop just on yield measurement. We go deeper to understand what is happening with the plants. So we measured first of all the relative water content in plants, and we find out that with the use of these biologicals we can preserve kind of what the plants from kind of extraordinary evaporation of water. But also we analyzed the relative gene expressions of the gene which visualize plant response to the drought. So here we also see that with the use of this product we could reduce plant stress from the drought. And how that looks in practice, in Italy in 2023 there was a problem with floods first, and then they have quite arid months. So we treated sorghum just soon after germination with 2 of the products, Azotohelp and Liposam. And when our team came to observe the difference in field, it was plus 46 outside, so quite hot even for human, not only for plants. But in the end, we measured increment on this trial for around 400 kilograms, even in such critical conditions. So on that, I want to thank you, but also to say, to give you more confidence that biologicals works, that's data from different parts of the world, that's data backed by thousands of trials, by our company, but by the industry. And I believe that place of biologicals in managing our challenges in agriculture are quite consistent, quite significant, and in our hands. Thank you.
Thank you, Dmytro. Please stay here. Maybe there are some questions. Any question from the audience? Anybody? Nobody? I have a question, and it's referred to what you now mentioned. I mean, and clearly robustness in trials and understanding your products already it's the key. But always in microbials it's challenging for when we are in a market to make the farmer understand, to make visible what the product is doing. I see you have specific products, you have products which seems more polyvalent, more robust. What's the best strategy you think when approaching microbials for farm systems?
Thank you for an interesting question. Indeed, working with biostimulants it's not easy because when you work with fertilizers, for example, or chemicals, sometimes you can expect high increments, and with biostimulants we have an average 10%, which is not so easy to catch by eyes sometimes. That is why in our approach with farmers we try to use the most novel instruments which we can use, for example, like biomakers do, or these biotracks, or the NVI indexes, and some specific foliar measurement of plants so that we can demonstrate and prove the real effect of the products. But secondly, normally on some markets which are developing, we start from those biologicals which are most easy to understand. And for this, I believe biofertilizers are quite simple because farmers get used to use nitrogen, they know it evaporates, and there are some limitations, especially in organic farming. And then for phosphorus, everybody knows it's blocked in soil and not used completely. So this idea is closer to farmers' understanding. And then we go with more sophisticated products like organic matter improvement, carbon technologies. With those technologies, we go already to kind of farmers which are on high level of maturity of understanding of agri-technology, regenerative approaches, and so on.
Thank you very much. Any other question? Please.
Yeah. Please, could you tell me about the... Hello. Please, could you let me know about the caducity of the product, the shelf life, the expiry date?
Yeah, thank you for a good question. Again, when we started working this industry, we work with kind of first generation products which have some specifics to work with, like around 1 year shelf life in cold conditions. But recent 10 years we worked a lot to improve the formulations because we understand products should be easy to apply and also easy to handle in distribution systems. So most of our products now have 2-3 years in normal temperature without specific conditions.
Okay, thank you. Question there as well?
Good morning. So first of all, thank you for your very interesting presentation. At a certain point, you mentioned your client in Czech Republic tried to compensate a huge amount of nitrogen in the soil. I was quite impressive, and from my point of view, it is a little bit risky because at the end of the day, after transit period, the final destination is soil depletion. So I would like about the nitrogen. So I would like to ask the reasons behind this. This test trial. Why your client asked to reduce this high amount of nitrogen? Thank you.
Yeah, thank you very much. It's a good question, and as our scientists say, we should not forget about the agrochemistry and the consumption of nutrients by plants and kind of ecosystem, etc. So we believe future is in integrated approach, but we can improve nutrient use efficiency by with biologicals. Normally, we don't recommend that high substitution, but more or less like 20-30 kilograms, so that we are more safe. At the same point, in some areas, like in Germany, for example, in Czech Republic, fertilization technologies and in general agro-technologies are quite intensive, and sometimes that happened historically by development of the industry, activeness of some producers, etc. So farmers just get used to use so high level of fertilization, and sometimes we see that we can cut it for 30-50% and don't get any reduction of the yield at all, even without applying anything. So in this situation, it especially makes sense to play with technology to try to find a new optimum amounts of nutrients. And again, in such cases, you can see such situations when you even can decrease such significant amount of nutrients without loss of the yield.
Thank you, Dmytro. Any other question? We have time for the last question, if you want. If I may add to the nitrogen, usually it's up to the farmer to decide, but if you want to get an idea of how strong your nutrient use efficiency is, probably it's where you need to do a strong reduction just to test the performance of the product.